like whisper something. Whenever you whisper something.
All right. Lunch is over now. It's time to pay attention. Here we go. Back to our exponents. Here we go. Take a look at the sky. Tell you what, take a minute and see what you can do by yourself. See how far you can get. Think about what we talked about before lunch. See how far you can take it. And then we'll see how you're doing. Braden, you got an answer?
Yeah.
All right, let's pop it right up here and put it up here, and we're all gonna look at it. If you're wrong, we'll just laugh. I'm kidding, come on. Get up here. Let's
You
see
want me to
what
write
you
it
got.
down?
I want you to write your answer right up here on the board, yep.
Are we supposed to do both of them, or just down?
Well, you can do the second one if you want. Like we're talking about the first one first. Write nice and big, so that you don't fix it. I know I did, that's my job.
You want me to like do my work too?
Just show your answer, we'll talk about your work if it's wrong. We're gonna see if everybody matches you.
I feel like this is definitely wrong.
I bet it's not, I bet it's right. All right, let's all take a look at Braden's work. And what do you think? What do you think? That's okay. That's all right. Doesn't be good to bring in work. What do you think about this? Boy, look at that. Are we in agreement? Okay, so if this is not what you got, let's talk about it. Did everybody get the 1/2 part? Because 3/6. Now, this 1 doesn't technically have to be written there. So we know we can take that out if we want. It's fine, it doesn't matter. How did he get x to the 8th? Explain it to me. Is hash?
Because you do 5 minus 3, but those negatives, the minus side and the negative cancel out, so it's really just 5 plus 3.
So, another, yes, exactly. Another way to think about it is, these 3 are gonna have to move up. There's already 5 of them up there. So if you got 5 up here and you move 3 up, it's gonna be x to the 8th, right? Perfect. How about the y's? Emma Ayers, you have any idea how he got y to the 9th here?
You subtract -5, but it becomes +9.
So, yes, so if you subtract, you actually get -9, but then you have to move it to the denominator, right? Another way to think about it is, you got 5 sitting down here right now, you're gonna move 4 more down, you're gonna have 9 of them down here. And z to the 6th, nothing moves there, but you got 8/2, right? Beautifully done. Thank you, Brayton, you did great. Anybody else have a question about that? Last exponent problem. You'll see one of these someday, big, hard, ugly thing like this, so let's walk through it. Remember, there are lots of ways to start the problem. So I'm gonna call on somebody and we're just gonna go with that, even though you might do the problem in a different order. Okay? So Sharon, how would you start?
Well, you distribute the negative 2 to everything.
Okay, so she wants to start by applying the -2 to everything. So if we start that way, which may or may not be the way you would start, and that's okay, we gotta end up at the same spot, right? So here we go. Oh, number 2 homework, yay! All right, so here we go. 4 to the -2nd, x to the what? What am I gonna do with these? Multiply, so -10, y to the 6th, z to the 16th, 8 to the -2nd, x to the -2nd, y to the 8th, and z to the -4th. Now again, you might not do it that way, but is that okay?
Yeah.
That's okay. All right, so now, given Sharon's first step, Allie, what would you do next?
Next I would, first apply the exponents to the, just the set numbers.
So take care of this right here?
Yeah.
Okay, so she says I'm gonna take care of my constants first,
That's
my
the way
regular
that's-
numbers. Now, keep in mind though, that that's a negative exponent. Please do not say negative 16, that's not what that is. That's gonna move to the bottom. That's gonna become 16 on the bottom, would you agree?
Yeah.
And similarly, that's gonna become 64 on the top. A negative exponent does not make your number negative. A negative exponent moves you. Okay, now what, Allie? In case you got that taken care of, now what?
Next I would move on to like the, why am I forgetting the names of like the letters?
So you want like terms, like the X's?
Like terms, yeah, okay. Do you want me to say like
What would you do with that?
Okay,
What
well-
are you thinking?
it's going to be, x to the 8th on the bottom, I believe.
I think she's right.
I agree.
Now, some of you can go straight there. Personally, I can't. I have to think about that as being x squared over x to the 10th, because that goes up and that comes down. But obviously, x squared over x to the 10th is x to the 8th on the bottom. So if you can go straight there, perfect. Somehow end up with an x to the 8th on the bottom. All right, what about our y's? That's a little easier, even for me.
Y, squared on bottom.
Mm-hmm. Everybody get that? 6 over 8? And how about my z's?
Z to the 20th on the top.
Perfect, because these are coming up. So it's gonna be 16 plus 4 or 20. You gonna put that in the answer blank and move on? No, cause what? What else needs to be done? Lauren?
You need to simplify 64 and 64.
Yeah, and that's what goes in, oh, the 61 to 64, I think it does, right? So it's 4z to the 20th over x to the 8th y squared. Does that look better to everybody? Now again, I'm gonna try not to say this too much, but the way you do the problem, the order that you do things in this problem doesn't matter. Eventually end up with this. Okay, all right, perfect. What's next? All right, now we've got scientific notation. Who knows what I'm even talking about when I say the words scientific notation?
Times 10 is.
So scientific notation is something times 10 to the something, right? That's about the crappiest definition ever, but isn't that what it is? Okay. Now, there's a rule though. You can't put just anything here. What do we know about the number that goes right here in this first spot? What is the rule for that number?
There has to be a decimal, but a number, one number.
Okay, one number in front of the decimal point. So like 6.3 or 5.8. One number in front of the decimal. We formally say that number has to be between 1 and 10, right? Something point something, one number. So when I look at 42,000, when you have a plain number and you don't see the decimal point, you know it's at the end. There's 5 numbers in front of the decimal point, can't be. So we're gonna move it. So there's only one number in front of the decimal, so 4.2. Now how do we figure out what number goes up here? Okay, I got my 2 best volunteers are just so eager to volunteer and I love it. Jake?
Based on how many times you moved this.
Exactly, and I moved this particular one 4 times, so that's gonna be times 10 to the 4th. Y'all took chemistry, right? So you've done this probably a million times. How about 0.00016? All right, so what's my number out in front there?
1.6,
1.6 times 10 to the
-4.
-4. Now, your chemistry teachers or whoever taught you this, I'm sure, gave you rules about, okay, if you move it left, it's one thing, if you move it right, it's one thing. I remember it, I have a really hard So I remember it, if the number is small, a small number, then the exponent is always going to be negative. If the number is big, like 42,000, the exponent will be positive. Doesn't matter to me how you remember it, just make sure this one has a -4 and that one has a +4. All right, now we're gonna put them together. We're gonna do some operations with scientific notation, and we're going to do it without our calculator. We don't need a calculator, at least for this one. We might get it out here in a minute. We don't need it for this one. I would suggest, one of the benefits of scientific notation is, you can deal with these two, and then you can deal with these two as two separate pieces of the problem. Okay, so we've got a 3.6 divided by a 1.2. What's 36 divided by 12? 3. So this is just 3. Now, these are both 10s. We just do our exponent rules. Some of you are going to subtract 19 minus -3, which is fine. I'm going to move this up. I have 19 up there. I move up 3 more. I'm going to get the same thing you get. I'm going to get 22. And there's my answer. Think about if you looked at this number all multiplied out, 36,000,000 divided by whatever that is, 0.0012 or whatever. Think how awful that arithmetic would be, but how easy it was to do it in scientific notation. That's why we have scientific notation. Makes that computation easier. Okay, how about the next one? I'm gonna let you use your calculator because this is not so easy. On this next one, if you have your calculator, great. If you don't, I have one, so it's no big deal. You can multiply by hand if you wish. But I would again start by multiplying those two numbers. So we're gonna multiply these two numbers together. Okay? So I'm just multiplying 1.5 times 7.6, and I got 11.4. Anybody else get that? Okay, so that's the numbers. Now, I have a 10 to the 6 times a 10 to the 9. So I have 6 tens and I have 9 tens. So altogether I have 15 tens. Now, be careful. You gotta put a circle around that, put it in the answer line. What's wrong with it? It's not in scientific notation. Now, we didn't make any mistakes. This is the way it came out. So we're right so far, but now we have to fix that. Because that can't be 11.4. That has to be 1.14. Agreed? Now, to get from here to here, I move the decimal point one place. So you hopefully get that exponent is going to have to change by 1, right? It's either going to go up 1 or down 1, but it has to change by 1. What do you think? Should I make it a 16 or make it a 14? What do you think, Meg? What?
16.
16, she says. And you know what? She's exactly right. Now, I get it's confusing. I've admitted to you, I cannot remember all the scientific notation rules. But here's the deal. This number and this number have to be equal, right? They have to be the same. So if I have made this part of the problem smaller, if I have gone from 11.4 down to 1.4, if this part's smaller, this part has to be bigger to counteract that. They gotta be equal. So that is exactly the right answer. Good work. All right, try E on your own. Try E, and please do it the same way. I don't care if you use a calculator to help you with the arithmetic. But let's take care of the numbers first, and then do the exponents. And then clean it up if necessary. I don't know what's going to happen. my first attempt, this is what I got. Did anybody get this first time through?
Yes.
Okay, so now then we have the same issue we had before, so we'll make it 1.0625. Now I gotta decide what to do with the exponent. So I'm making this smaller, making that bigger. Did you get times 10 to the third? Perfect, you guys are absolutely magnificent. One little caution, oh, yep, go ahead. Mhm.
So have you ever round that up to like 1.06, or do I have to have the 2.5?
It would depend what the directions said, but remember, when you are rounding in scientific notation, you're really rounding a whole bunch, because this number is 1062.5 if I wrote it out in bigger. So if you rounded it off to 1.06, you would actually have 1060, so you're actually losing 2.5. So it's probably better not to round, but if I had done that and this would have turned out to be, then I probably would have rounded. So what I'm saying is really no answer at all, except just use your common sense. If it's too huge, round it off. All right, great question. Anybody else? Okay, let's look at my caution on there. This is one of the big time mistakes that's made. These two are not the same thing. Does everybody understand that? They are not the same thing. And sometimes when you're in the middle of a problem, you kind of get in a rush and you lose focus. You can't. These negatives can make a huge difference, so pay attention. What would this be? What would this answer be? Negative 16. This one would be positive 16. Yes, there's a difference. So just pay attention to that. You got it. Okay, so we just finished P1, so that homework will be due on Tuesday. If you have a resource later today, you get it done, you can bring it on in like Brendan did earlier, or you can wait till in Monday or Tuesday. It's due Tuesday at the end of the school day. Okay, everybody clear on that? P1, we're gonna do P1, where Rick Rock put it in. We are not done for the day, do not put your notes away. Oh, no, you've got 6 minutes, we're rolling. All right, here we go, P2. You paid 16 grand for this education, folks. We are going to make sure you get your money's worth. All right, so little vocabulary. I think I have everything labeled. A little vocabulary here. Anybody, first of all, does anybody know what this whole setup is called? What do we call this thing? Well, we graph on it, that's for sure. Coordinate plane. What kind of coordinate plane? It actually has a name, because there are different kinds of coordinate planes. You're going to be so excited when we get to a later chapter, like chapter 6. We're going to graph in a circular system called a polar coordinate plane instead of this one. Well, no, but you're close. Everything is based on a rectangular system. So sometimes this is called a rectangular coordinate system, but its real name is the Cartesian coordinate plane. I don't know if any of your history classes have talked about Rene Descartes, one of the great philosophers. He was also a great mathematician. And he is credited with being the first person to draw pictures of math, which is what you're doing when you plot points and connect them, make circles and stuff. Okay, so it's called the Cartesian coordinate plane. It's rectangular because don't you plot points by going over and up or left and down, something like that. So it's that perpendicular movement. That's why it's called rectangular. Okay, what do we call this point right here in the center?
0, 0.
Well, its coordinates are 0, 0, but it has a name. Origin. It's called the origin. Have you heard that before? It's called the origin. Now in polar coordinates, when we get to that circular system, it will be called the pole, like the North Pole, P-O-L-E. But right now, it's called the origin. Okay, what do we call this line? That's the x-axis. And this one is the y-axis. We need a way to communicate with each other. If you're talking, as I'm sure you often do, on the phone with people about your coordinate plane, you need to have a way of communicating. Language. What do we call this section of the coordinate plane? Quadrant 1. Roman numerals, standard notation, quadrant 1. Where does 2 go? They go in order, so is 2 over here or is 2 down here? Over here. Yep, they go counterclockwise. So 1, 2, here's 3, and here is 4. Now that's standard vocabulary. I know you've seen it before. If you're a little bit fuzzy on it, just practice it a few times so that you don't make mistakes with that. A little bit of vocabulary. All right, let's get number 2 done, and then we'll be done for the day. I promise. I'll figure it out. So here we go. Where am I going to put? I'm going to plot some points now. Where am I going to put 1, -1? Where's it going to go, Katie?
One to the right and one down.
Exactly. And when it says label, just put a little 1, -1 right next to it, or under it, or by it somewhere. That's the point that you're plotting. When we're not using graph paper, it's important that we are labeling. If you are a person that really needs graph paper, I have a bunch. See that shelf back there under the flag on top of the refrigerator that has the angels on top of it? It's got graph paper in it, if you ever need graph paper. All right, 2, 0. Where am I putting it?
2 to the right, and
2
that's
to
it.
the right here. That's the point 2, 0. Okay? This point is not in a quadrant. This point is on the positive x-axis. And finally, -3, -2. Left, 3, 3, 2. Yep, left 3 and down 2. -3, -2. And there it is. All right? All right, let's get gathered up so you can head on out. I will put in my attendance.
You know what?
By the way, does anyone think you might need additional property practice? I have a sheet that I use in college prep, which I'm happy to give anybody else who wants additional property practice. Anybody want to practice? All right. Have a good day, people. Get that homework done, guys. Hey, get your homework done during recess. All right. Are you in the same recess?
It's no. I'll see you there.